ल अब यसको एप्लिकेसनसम्म याद गर है त वाट आर द एप्लिकेसन भनेको 3-4 वटा याद गर तिमीलाई त्यति धेरै त नसोध ल अब हेर हाम्रो फर्स्ट युनिट चाहिँ कम्प्लिट भयो है 8.1 अब हाम्रो 8.2 नै हो यो फाइनल युनिट हो तर अलि धेरै लेन्दी छ बुझ्यौ यो लेन्दीमा पनि अलि मैले तिमीलाई अलि धेरै लेखाइदिएको पनि छु त्यो हेर्न सक्छौ सजिलो तरिकाले मैले त्यहाँ लेखेको छु हेर है त ल हेर अब यहाँ हामीले पढ्ने कन्टेन्टहरु के हुने त इन म्याग्नेटिक फिल्ड वी स्टडी different topics. These are the topics that are to be studied here at this unit, at this chapter. What are they? One is magnetic flux, magnetic force and torque. You know about magnetic force or force on moving charge inside the magnetic field, force on current carrying conductor inside the magnetic field, and you know about the torque on current carrying conductor inside the magnetic field. You know about Hall effect. You know about Hall effect, and here we study about cyclotron. What is cyclotron and what is its working? What is synchrotron? यी दुईटा तिम्रो लागि नयाँ हो हल इफेक्टमा पनि अलिअलि नयाँ थोरै 1-2 टर्महरु नयाँ हुन्छ नत्र यो पढिसकेका छौ म्याग्नेटिक फ्लक्स पनि पढाएको छ म्याग्नेटिक फोर्स पनि तिमीले पढाएको छौ टर्क पनि पढिसकेका छौ हल इफेक्ट पनि तिमीले पढाएको छौ थोरै मात्रै हामी थप्छौं साइक्लोट्रोन सिम्पल छ खासै धेरै गाह्रो छैन तिमीले चाहिँ पढाएको छैन तर नयाँ हो सिन्क्रोट्रोन पनि नयाँ हो है त यो साइक्लोट्रोन र सिन्क्रोट्रोन एउटै हो है एउटैमा पढ्छौं हामी अनि अर्को म्याग्नेटिक फिल्ड बायोट-सावर्ट्स ल तिमीले पढिसकेका छौ बायोट-सावर्ट्स लका डिफरेन्ट एप्लिकेसन छन् नि त्यो मध्ये यहाँ तिमीलाई म्याग्नेटिक फिल्ड ड्यू टु करेन्ट क्यारिङ सर्कुलर लूप यति मात्रै भनेको छ तर हामीले 1-2 एक्स्ट्रा पढाउँला केही छैन अनि एम्पियर सर्क्युट ल तिमीले पढिसकेका छौ मैले खासै सोध्दा मात्रै हुने हो तिमीहरुलाई म्याग्नेटिक फिल्ड आउटसाइड एन्ड इनसाइड द लङ स्ट्रेट वायर क्यारिङ कंडक्टर बाय युजिङ एम्पियर्स ल Another topic is electromagnetic induction, Faraday's laws of electromagnetic induction and energy transformation. Induced electric field, यो तिमीलाई अलिकति नयाँ होला एउटा टपिक सेल्फ एन्ड म्युचुअल इन्डक्सन LR सर्किट energy stored in magnetic field, energy density of magnetic field, expression for energy density of magnetic field, induced magnetic field and displacement current. These are the content, these are the topic that are to be studied at this chapter. अब तिमीले यति पढेपछि तिम्रो सबै च्याप्टर सकिन्छ बुझ्यौ ल अब म 1 by 1 भन्दै जान्छु र सजिलो छ तिमीले सुनेर एकचोटी पढ्यौ भने भइहाल्छ व्हाट इज म्याग्नेटिक फ्लक्स अब स्टार्टिङ एकदम सिम्पल बाट स्टार्ट गर म्याग्नेटिक फ्लक्स means the total number of magnetic lines of force passing normally through a surface. The total number of magnetic lines of force passing normally through a surface is called magnetic flux. That is called magnetic flux. And also, what is magnetic flux density? What is magnetic flux density? The magnetic flux per unit area. The magnetic flux per unit area is called magnetic flux density. That is B equal to phi B by A. Phi B means magnetic flux. Phi is the symbol of flux and B is magnetic field. That is the symbol of magnetic field. So you can write phi B by A. Magnetic flux per unit area. That is called magnetic flux density. So from this formula you can say phi B equal to B times A. B times A. It means that magnetic flux is the product of and surface area. Magnetic flux density and surface area. That is the magnetic flux and its unit is Weber. The unit of magnetic flux is Weber. Now you can represent this flux in integral form also, in integration form also. For that, let us say or let us denote this is the surface area. This is the surface having whole area A. Having whole area A. Now let us take the elementary area dA of the surface. Here we are choosing the elementary surface dA of whole area A. हैन A area को elementary area तिमीले यहाँ choose गर. Here we are taking the elementary area dA of this whole area A. And the magnetic field is acting along this direction. Let us suppose, and it makes an angle theta to the normal of this surface. हो योसँग यसले बनाएको एंगल कति छ थीटा छ normal to the surface area. ठीक छ अब हेर त यो थीटा छ भने अब के भयो त भन्दाखेरि magnetic flux is defined as the magnetic flux this if the surface area is elementary. Here we are choosing the elementary surface area, and if the surface area is elementary, the magnetic flux is also elementary. Magnetic flux is also elementary. So the elementary magnetic flux that passes through the elementary area dA is given by d phi b. D phi b equal to component of B normal to the surface, component of B normal to the surface, and surface area. That means d phi b equal to B perpendicular times dA. What is B perpendicular here? B perpendicular is B cos theta times dA. B cos theta times dA. So d phi b equal to तिमीले A cos B A dot B गर्यो भने के हुन्छ? AB cos theta हुन्छ नि हो त्यस्तै जस्तो B dot dA गरे B dot dA. That means d phi b is equal to B dot dA. This is the scalar product of B and surface area dA. Then what will be the total flux through the whole area? The total flux through the whole area can be obtained by integrating this term over the surface area. Yes. So the total flux through the whole surface area is given by, or through the whole area is given by phi b equal to integration, surface integration of B dot dA. And if you denote the surface as ds, then you can write B dot ds. B dot ds. यहाँ surface area लाई यस नलेखिकन ए लेखे हुनाले dA लेखेको, यस लेखे पनि हुन्छ नि B dot ds. B dot ds. हैन B dot ds. Hence the magnetic flux through an area is the scalar product of magnetic flux field and area. It is a scalar quantity and its unit is Weber. The unit of magnetic flux is unit Weber. And from this expression, you can conclude that surface integration of any vector, gives the flux of that vector. तिमीले यति याद गर. अब फाइनल कन्क्लुजन तिमीले के याद गर भन्दा कुनै पनि भेक्टरको सर्फेस इन्टिग्रेसन लियो भने त्यो भेक्टरको त्यहाँ फ्लक्स पत्ता लाग्छ. बुझ्यो? Surface integration of any vector gives the flux of that vector. This is our conclusion from here. We can draw the conclusion from here. What is that conclusion? The conclusion is that the surface integration of any vector gives the flux of that vector. And if you are going to determine the electric flux, then what will be the notation? That means phi equal to electric flux phi equal to surface integration of E dot dA or E dot ds. E dot ds. That is the flux of electric field. Flux of electric field. अब यहाँ phi E भनेको के हो? Surface integration of E dot dA or E dot ds. जेसुकै लेख हैन. अब if you have a vector A, here the vector is E. If you have a vector A, then what is the flux of A? The flux of A is given by surface integration of A dot ds or A dot dA. And flux similarly, if you have a vector B, then phi of B equal to B dot ds. This is the symbolic representation or integral form of flux of any vector. Flux of any vector. This is about magnetic flux. Now, another topic is force on moving charge inside the magnetic field. अब यो त मैले खासै तिमीलाई पढाउनु पर्दैन. Force on moving charge inside the magnetic field तिमीले डिटेलमा क्लास 12 मा पढाएको छ. Suppose this is XYZ plane. A charge is moving in space whose magnitude is Q. Whose magnitude is Q. The charge is moving with velocity V. The charge is moving with velocity V in YZ plane. In YZ plane. And the magnetic field is applied along Z direction. The magnetic field is applied along Z direction. Then this moving charge experiences a force. This moving charge experiences a force. And it is found that the magnitude of force experienced by this moving charge inside the magnetic field depends on these three factors. One is it is directly proportional to the magnitude of magnetic field strength. That is B. The force experienced by the moving charge is directly proportional to B. ठीक छ यो? यो त केही गाह्रो कुरा भएन हो? It is also directly proportional to Q. Magnitude of charge. F is directly proportional to Q. And another is it is also directly proportional to the component of velocity. component of velocity perpendicular to the direction of magnetic field. This is the velocity, and it has velocity is a vector, and it has two components along this direction and along this direction, and theta is the angle. Here theta is the angle made by the moving charge with z axis. With z axis. So what is the component of velocity perpendicular to the direction of magnetic field? Along this direction b sin theta, and along perpendicular direction this is b sin theta. This is b sin theta. So the force experienced by the charge is also proportional to the directly proportional to the component of velocity perpendicular to the direction of magnetic field, that is b sin theta. That is b sin theta. Now combining all the statement we get, F is proportional to b q v sin theta. That means F equal to k b q v sin theta, where k is constant and its value is taken as unity. That means 1 in SI. And if you substitute the value of 1, then k equal to 1, then F equal to b q v sin theta. This is also called Lorentz magnetic force. This is also called Lorentz magnetic force. Now you can apply different special cases here. For that, if you suppose theta equal to 0 degree. What does it mean? Theta equal to 0 means the charge is moving along the direction of magnetic field. The charge is moving along the direction of magnetic field, then theta equal to 0. And if theta equal to 0, then the value of sin theta equal to sin 0 equal to 0. You know? No. 0 हुन्छ. जब theta को value 0 भयो भने f को value पनि के भयो? 0. That means no force is experienced by the moving charge, or no force is experienced by the charge if it is moving along the direction of magnetic field. This is one special case. And another is if you suppose that theta equal to 90 degree. Theta equal to 90 degree. If theta equal to 90 degree, that means the charge is moving perpendicular to the direction of magnetic field. The charge is moving perpendicular to the direction of magnetic field. Then the value of sin 90 is equal to 1. The value of sin 90 is equal to 1. When sin 90 is equal to 1, then maximum force is experienced by the moving charge. That means BQB. BQB, which is F max. BQB. अब जुन डिरेक्सनमा म्याग्नेटिक फिल्ड लगा त्यही डिरेक्सनमा यदि हिँड्यो भने त्यो बेला sin 0 equal to 0 भयो. sin 0 equal to 0 हुने बित्तिकै F को भ्यालु के भयो त? 0 भयो. यसको मिनिङ no force is experienced by the charge if the charge is moving along the direction of magnetic field. But if the charge is moving perpendicular to the direction of magnetic field, then the charge experiences maximum force. Maximum force. And which is given by F equal to BQB. And if an electron is moving inside the magnetic field, then the maximum force experienced by the electron is BEB. BEB. ठीक छ? अब यदि एउटा इलेक्ट्रोन भएको भए त्यो मुभिङ चार्ज एउटा इलेक्ट्रोन भएको भए के हुन्थ्यो? BEB हुन्थ्यो हैन? BEB. Now third case is when B equal to 0. What is the meaning of B equal to 0? B equal to 0 means the charge is stationary inside the magnetic field. The charge is stationary inside the magnetic field. When the charge is stationary inside the magnetic field, then F equal to 0. F equal to 0. B, since B equal to 0. At this case also, the charge experiences no force. That means no force is experienced by the charge when it is stationary inside the magnetic field. And in vector form, the force experienced by the moving charge inside the magnetic field can be represented by the formula F equal to Q times B cross B. And the direction of Lorentz magnetic force. This is the formula for Lorentz magnetic force. And the direction of Lorentz magnetic force can be obtained by Fleming's left-hand rule. Fleming's left-hand rule. Again, F equal to BQB. Again, BQB. यो Lorentz magnetic force बाट Fleming's left-hand rule बाट तिमीले direction find out गर्न सक्छौ. है त? Now, what is Lorentz force? What is total Lorentz force? If a charge is moving in space and the space has both electric and magnetic field, so the total force or net force experienced by a moving charge in space, that is in electric and magnetic field, is called total Lorentz force, and that is the sum of force experienced by the charge in electric field and in magnetic field. In electric field and magnetic field, that is F equal to Fe plus Fp. What is Fe? Fe equal to QE. हैन एउटा चार्जलाई इलेक्ट्रिक फिल्डमा पठायो भने उले एक्सपिरियन्स गरेको फोर्स चाहिँ QE हुन्छ. एउटा इलेक्ट्रोनलाई पठायो भने के हुन्छ? EE हुन्छ. E plus Q times V cross P. Q is common here. E plus V cross P. This is called total Lorentz force, or this is the equation of Lorentz force. Total Lorentz force, that is the force experienced by a charge in space, that is called total Lorentz force. Now, what is Fleming's left-hand rule? Fleming's left-hand rule states that if we stretched the forefinger, middle finger and thumb of our left hand such that they are mutually perpendicular to each other, एउटा लेफ्ट ह्यान्ड का तीनटा औंला, बुढी औंला, चोर औंला र माझी औंला, यिनीहरुलाई तिमीले म्युचुअली परपेंडिकुलरली स्ट्रेच्ड गर्यो भने के हुन्छ? यस्तो किसिमले स्ट्रेच्ड गर्यो कि तिमीले if the direction of forefinger points the direction of magnetic field, the direction of forefinger gives the direction of magnetic field, and the direction of middle finger shows the direction of motion of the charge. The direction of middle finger gives the direction of motion of the charge. Then the direction of thumb, or the direction in which the thumb points, gives the direction of Lorentz magnetic force. हैन तिमीले स्ट्रेच गर्यो भने F equal to BQV भने F भनेको थम्बले रहेछ, B भनेको फोर फिंगरले रहेछ, V भनेको मोशन अफ द चार्ज भनेको के रहेछ? मिडल फिंगरले रहेछ. F equal to BQV, and that law is called Fleming's left hand rule. Now, force on current carrying conductor inside the magnetic field. Suppose you have a current carrying conductor and that current carrying conductor is placed inside the magnetic field. Then this current carrying conductor also experiences a force, because we have already studied that if a charge is moving inside the magnetic field, then it experiences force. And we know every conductor consists of large number of free electrons and they are moving inside the conductor here and there. That means they are in motion. And each free electron experiences a force inside the conductor. So we can say that a conductor also feels some force when it is placed inside the magnetic field. That means when a current carrying conductor is placed inside the magnetic field, it also experiences a force, and which is perpendicular to both magnetic field and current carrying conductor. Now let us suppose this is the conductor. We have a conductor having length here, and this is XYZ plane. The magnetic field is acting along Z axis. This is, and here the conductor is placed in YZ plane like this. And the current I is flowing through the conductor. And you know, if A is the cross section area of the conductor and L be its length, then what will be the volume of the conductor? The volume of the conductor is given by V equal to AL. And this is the axis of the conductor. And the axis of the conductor makes an angle theta to the direction of magnetic field. The axis of the conductor makes an angle theta to the direction of magnetic field. Here, first of all, you should determine the total number of free electrons inside the conductor. And you have already derived the force experienced by a free electron, by a charge inside the magnetic field. So let us determine the total number of free electrons inside this conductor. For that, we consider a conductor having cross section area A and length L. Then the volume of the conductor is given by B equal to AL. Now this conductor is placed inside the magnetic field, and the magnetic field is applied along Z direction. And theta is the angle made by the axis of the conductor to the magnetic field. Then the total force experienced or the force experienced by this conductor, the force experienced by this conductor is equal to the total force experienced by all the free electrons of the conductor. So at first you should determine the force the total number of free electrons inside the conductor. And we know this conductor consists of large number of free electrons and they move in random direction before the application of electric field. Now, the force experienced by a single electron inside the electric field is BQB sin theta. BQB sin theta. Here the charge carried by single electron is E. So you should write the force experienced by an electron inside the electric field is F dash. F dash is force experienced by a single electron, free electron inside the electric field, inside the magnetic field is equal to BQ is replaced by E. BEBD sin theta, where BD is the drift velocity of the electron. Now, if we suppose that N be the number of free electron per unit volume, N be the number of free electron per unit volume, then what will be the total number of free electron inside the conductor? The total number of free electron inside the conductor is given by N equal to NB. N equal to NB. ठीक छ? अब यहाँ N भनेको N नै भयो, B भनेको AL हो, N times AL. This gives the total number of free electron inside the conductor. Now, this is the force experienced by single electron, one free electron, and these are the total number of free electron inside the conductor. Then what will be the total force experienced by all the free electron inside the conductor, and which is nothing but which is also the force experienced by all the conductor. The total force experienced by all the free electrons inside the conductor is same as the force experienced by the conductor inside the magnetic field. So we can say the total force experienced by all the free electrons inside the conductor is N times AF dash, N times F dash, where N is total number of free electron and F dash is force experienced by one electron, one free electron, right? What is the value of N? N equal to NAL. Here, NAL, you know, F dash is BEBD sin theta, BEBD sin theta, oh, BQB sin theta. अब हेर त NAL BEBD drift velocity को फर्मुला के हो? I by NE हो के न? I equal to भेना तिमीले डिराइभ गरिसकेका छ हो के न? भनेपछि NEA क्यान्सल भयो. What are the remaining term? Remaining term are F equal to BIL sin theta. BIL sin theta. This is required expression for force experienced by a current carrying conductor inside the magnetic field. What is the force experienced by a current carrying conductor inside the magnetic field? This is BIL sin theta. And here also the value of F depends on theta. That means the orientation of the conductor inside the magnetic field. And if you suppose that theta equal to 0 degree, that means the conductor is placed along the direction of magnetic field. है ना? अब तिमीले त्यो कन्डक्टरलाई यसरी राख्यो, म्याग्नेटिक फिल्डसँग प्यारलल हुने गरी राखिदियो, यसरी राख्यो हो कि हैन? यसरी राख्यो. थीटाको भ्यालु 0 भयो. थीटाको भ्यालु 0 भएपछि sin 0 को भ्यालु 0 हो. भनेपछि f को भ्यालु 0 भयो. भनेपछि यदि तिमीले यो कन्डक्टरलाई म्याग्नेटिक फिल्डसँग प्यारलल हुने गरी राख्यो भने यो कन्डक्टरले म्याग्नेटिक फिल्डमा कति पनि फोर्स एक्सपिरियन्स गर्दो रहेनछ. That means no force is experienced by a current carrying conductor when it is placed parallel to the or along the direction of magnetic field. But if this conductor is placed along this direction like this, okay, that means theta will be 90 degree. When theta is 90 degree, then what will be the value of sin 90? That is 1. Which means maximum force is experienced by the current carrying conductor when it is placed inside the magnetic field in perpendicular direction. That means theta equal to 90 degree, F max equal to BIL. This means that maximum force is experienced by a current carrying conductor when it is placed perpendicular to the direction of magnetic field. Perpendicular to the direction of magnetic field, and in vector form you can write F equal to I times L cross B. L cross B. This is the vector form of force experienced by current carrying conductor inside the magnetic field. Now, Another topic is torque on rectangular current loop. तिमीले torque on current carrying rectangular coil भनेर पढाएको छ बिना हो कि हैन बिना cos theta when it is placed by making some angle to the direction of magnetic field, that is बिना cos theta, and maximum force torque is बिना only. हो त्यही कुरा यहाँ हामीले एउटा लुपमा मात्र हेर्न खोजेका छौं बुझ्यो अरु केही हैन यहाँ लुपको कुरा हेर त फर्मुला त्यही नै हो नि एउटै हो अब हेर यो तिमीले नि जानिहाल्छ यो कुरा torque on a rectangular current loop. Suppose this is PQRS is a rectangular current loop that carries the current I. That means current I is flowing through this loop. Loop भनेपछि एउटा टर्नको मात्रै कुरा हुन्छ okay, and let us suppose PQ equal to L, this is the length, and QR equal to B is the breadth of the loop. Then what will be its area? Its area will be L times B. Area will be L times B. Now this current carrying loop is placed inside the magnetic field. This is placed inside the magnetic field. अब यहाँ magnetic field भित्र यसलाई राख्यो हैन यहाँ magnetic field देखाएको रहन्छ तिमीले देखाउन सक्छौ हैन यहाँ यता n पोल यता s पोल ठीक छ त्यो गर ल now it is placed inside the magnetic field. Then what happens? You know that every current carrying conductor experience a force when it is placed inside the magnetic field, by which a turning effect is produced in the loop. So that this loop now starts to move in anti-clockwise direction here like this. That means torque is produced in the rectangular loop. Now here you see that the two sides PQ, the magnetic field is acting along this direction here, and the two sides PQ and SR are perpendicular to the direction of magnetic field. The two sides PQ and SR of this current loop, rectangular loop, are perpendicular to the direction of magnetic field. So they experience maximum force. They experience maximum force. What is the expression? The expression is BIL. BIL. So the force on the side PQ is F1 equal to BIL, and the force on the side SR is also BIL. BIL. They are equal in magnitude, but they are acting through the two different line of action. So they form a couple of force. And due to couple of force, a turning effect is produced, and which is called torque. And what is torque? Torque is tau equal to either force into perpendicular distance between the forces. Either force, that means one force times perpendicular distance between the forces. And the forces on the side QR and PS, they are equal in magnitude. That is BIB sin theta. BIB sin theta. BIL भने ठाउँमा के छ? B छ. BIB sin theta. They are equal in magnitude, but they are acting in opposite direction through the same line of action. So net effect of F2 and F4 is equal to 0. That means no turning effect is produced by the forces F2 and F4. So turning effect is produced, which is called torque, is due to the forces F1 and F3. So you should use the formula here, tau equal to either force times perpendicular distance between the forces. Either force times perpendicular distance between the forces. अब हेर त either force भनेको BIL भयो ठीक छ. What is the perpendicular distance between the forces? From figure यहाँ हेर त यो फिगरबाट यो F1 हो यो F3 हो हैन यो F1 हो यो F3 हो यो F1 हो. यी दुईटा बीचको perpendicular distance भनेको यहाँदेखि यहाँसम्मको distance हो यति हो ठीक छ. NM is the perpendicular distance between the two forces. NM is the perpendicular distance between the two forces, and this can be obtained from this right angle here. हेर त यसमा cos theta, this is B breadth हैन यो भनेको B हो नि यो B हो भने यो पनि B नै हो यो पनि B नै हो हैन त. अब भनेपछि हेर cos theta equal to Mn by B, base by hypotenuse, Nm by B. That means Mn equal to क्या आयो त भन्दाखेरि B cos theta. Mn equal to B cos theta. That is the perpendicular distance between the forces is B cos theta. There B cos theta. अब L into B भनेको के हो भने त what is L into B? That is the area of the loop. That is the area of the loop. Tau equal to BIA cos theta. BIA cos theta. This is required expression for torque. This is required expression for torque experienced by a current carrying rectangular loop. Experienced by a current carrying rectangular loop when it is placed inside the magnetic field. When it is placed inside the magnetic field. ठिक छ? बुझिन्छ नि यो? खासै गाह्रो छैन होला है? ल यो हेर है त राम्रोसँग. ल यो भइहाल्यो. अब यसबाट यो त भयो एउटा लुपको मात्रै कुरा. तर यदि तिमीले मानौ एउटा रेक्टेंगुलर कोइल छ. If you consider you have a loop or you have a coil having n number of turns. You have a coil having n number of turns. Then what will be the expression for torque? The expression for torque will be bina cos theta. B-I-N-A, bina cos theta. Bina cos theta. And here you see that the value of tau depends on theta. The value of tau depends on theta. And what is the value of I-N-A? The value of I-N-A is denoted by M. I-N-A is denoted by M. And which is called magnetic moment of the current loop. Which is called magnetic moment. I-N-A भनेको magnetic moment हो. ठीक छ? अनि चाहिँ MB cos theta भयो. MB cos theta. This is required expression for magnetic torque experienced by a current carrying coil or current carrying loop having n number of turns. Having n number of turns. Now, in case first, if you suppose that theta equal to 0 degree. What does it mean? It means that the plane of the coil is parallel to the direction of magnetic field. Plane of the coil is parallel to the direction of magnetic field. At this case, cos theta equal to cos 0 equal to 1. When cos theta equal to cos 0 equal to 1, then tau equal to MB or bina, and which is the maximum torque experienced by the loop. Which is the maximum torque experienced by the loop. Similarly, if you suppose theta equal to 90 degree, then tau equal to 0. That means no torque is experienced by the loop if the plane of the loop is perpendicular to the magnetic field. If the plane of the loop is perpendicular to the direction of magnetic field. ल, this is about torque. हामीले दुई तीनटा कुरा पढ्यौं. Magnetic flux पढ्यौं, हैन? त्यसको फर्मुला पढ्यौं. अनि त्यसपछि force on moving charge inside the magnetic field, which is called low range magnetic force, त्यो पढ्यौं. Total low range force, त्यो पढ्यौं. Force experienced by a current carrying conductor inside the magnetic field, त्यो पढ्यौं. Torque experienced by a current carrying loop or current carrying coil inside the magnetic field. र यो कुरा हामीले पढ्यौं है त. अब यो पछि हेलो
सुनिरहेछ सर.
ए ल यो अहिले पढेका कुराहरु त बुझिन्छ नि हैन?
बुझिरहेछ सर. बुझिन्छ सर.
केही गाह्रो छैन है तिमीहरुको, केही गाह्रो छैन. अब संख्या पनि घटेर फेरि 31 मा के गरौँ, अझै पढौं
सर? आजलाई यति गरौँ.
आजलाई गरौँ न सर भयो.
अब यहाँ सुन, फोर्स लर्निङ गर्नु हुन्न क्या कहिल्यै पनि. रिजोनेन्स लर्निङ गर्नु पर्यो. बुझ्यो?
एकचोटी धेरै नि पढ्न नसकिन्छ सर, बुझ्दै बुझ्दैन.
हो, त्यही भएर मैले फोर्स लर्निङ गरिन. रिजोनेन्स लर्निङ गर्नलाई तिम्रो कुरा नि बुझ्नु पर्यो नि मैले.
हो सर.
ल यति गरौँ त आज.
हुन्छ सर.
हुन्छ सर.
अब सुन त, तिमीहरुले त्यो नोट पाइसक्यो भनेपछि भोलि हल इफेक्ट यसो हेर हेर त. तिमीले पहिला पनि पढिसकेका छौ. हल इफेक्ट र साइक्लोट्रोन भोलि पढाउँछु है त.
ओके सर.
ल ल बाई गरे है त. ल गुड बाई अल एन्ड थ्यांक यू.
रेकर्डिङ अफ गर्दिनु.
थ्यांक यू सर.
ए ल ल ल ल रेकर्डिङ अफ. यहाँ कुरा गर्दै जाँदा बिर्सिन्छ के. ल
लिभ गर्दा हुन्छ.
हुन्छ हुन्छ